Hey, welcome back. So in my last video, I was talking about SQS and lambdas and batches and how to know if a batch was done processing through lambdas and SQS queues and things like that. And Newton's third law, as soon as I posted a wrong answer on the internet, I got kind of right answers right away. And really what I found out was I had a big flaw in the code that I wrote. And so in this video, I'm going to talk about that flaw, talk about what went wrong, some potential solutions and why none of them really work, and then talk about what the next steps are going to be. So just to kind of go back and recap from the last video, there was a process that we had helped a client build where they were processing large batches of information, large records, one-offs, one by one, using a Lambda function to queue up a bunch of messages in SQS, and then another Lambda function to process those messages. And they wanted to know how to be notified when that batch was done processing. And we tried to give an answer. But there was a big flaw with this, which is Dynamo DB is a very good, very resilient system, but it does still fail. As Werner said a couple of years ago during reInvent, everything fails all the time. And when I was testing this, I was actually doing it in fairly small batches, somewhere around 1,000 to 10,000 records. And it turns out failures can still occur, but you usually have to do batches larger than that to catch this. So batches of say 100,000 to even 250,000 records, now you start to see problems. So if we go back to the original solution where I was using just a basic atomic counter in Dynamo DB, what I was finding is once I ran 100,000 records through the system, my remaining value on that batch state record was not being set to 0. It was actually being set to a negative number, and sometimes a pretty large negative number. So let's talk about that first. So the reason it was happening was because behind the scenes when I was doing this atomic counter update with DynamoDB, I was saying decrement this number by 1, and sometimes that fails because hardware and software just fail sometimes. Now, that failure is transparent when you're using the AWS SDKs like I'm using, and it then gets reapplied. So what can often happen is you get that count twice. So I'm decrementing twice when I should only be decrementing once. And that's how we end up with this large negative number. These decrements happen, it fails, it's reported as a failure, even though it's still made it to the database level. So the client then retries, and now it's applied it twice. Now, this was something that was brought up really quickly by Jan in my LinkedIn post, and I thank him for that. It's always good, sharing this information and learning, and mistakes are made. But I forgot the cardinal rule was which you have to plan for failures. So he shared with me an article, and I'll include it here in the description of this video too, talking about a blog article from AWS talking about all the different alternatives. And I'm going to walk through each one of them one by one and talk about why none of them work. So in the first one, it's the basic atomic counter. This is what I already implemented, but it doesn't work well when you have a number that has to be exact. If you're a little lenient with it, if you're going to try to increment numbers or decrement numbers, and you either have a reconciliation process or you're okay if you're maybe off a little bit here and there, then it probably is going to work okay. But in my situation, I can't be off because the way that the finalizer works is it's looking for a very specific value, a remaining of 0 in the system. And if that number isn't accurate, then nothing's going to work. And even if Dynamo DB streams and filters worked off of being able to say less than or equal to 0, it still wouldn't be accurate because I could have hit that 0 number or a negative number before the batch was actually done because the number of retries that occur in the system. So option number 2 is using optimistic concurrency controls. This is a case where you have effectively an E tag on the record. You read the record out, you try to apply the change back, and if that E tag is changed, you consider it already applied. But this is problematic in a really highly concurrent system like what this batching process is going to be. I have 100,000 records. That's kind of the standard I'm running with now in tests. And a lot of these records are going to be processing in parallel. So with optimistic concurrency, you're going to run into a lot of retries, and that's really going to chew through a lot of processing time in Lambda, a lot of read and write capacity units in Dynamo DB, and it's just not very effective, and it's not a good solution. You could also do an optimistic concurrency with history. This is the third option in the blog article, but the problem with it is that the E tag that they talk about using and having that grow over time, 100,000 records, even if you could somehow come up with a very, very efficient E tag, you're still going to blow out your DynamoDB object considerably. So option 3 also not going to work real well with simply because of the scale of this problem here. Option number 4 is using transactions with a client request token. Now I tried this, but unfortunately with client request tokens and transactions, again, in a very highly concurrent system, and I think the blog even calls this out, it doesn't work. You end up doing way too much reprocessing, and again, it blows out your Lambda runtime, and it blows through all of your read and write capacity units, and it becomes a very expensive solution overall. Transactions with a marker item, same problem. So option number 5, not going to work. Having that marker item on there, just not effective. So how about option 6, counting with an item collection? So in this case, it's kind of what we already have with the item state records, but there's a very high cost in querying and resolving when the batch is done. So, we've got this checking for a record, checking to see if there are enough of those records in the system. If we have that matching our batch state, this could get very expensive, and especially because now we're going into a polling mechanism. The trick about that is that a polling mechanism is constantly rerunning, and if you are hitting a lot of reruns where you have not met that state you're looking for, those are kind of wasted runs and extra costs, and becomes a very cost ineffective solution. And tuning that to make it cost effective can be very problematic and very inefficient, and just wasting a lot of cycles on that. So potentially an option, but there's a lot of caveats with it. And then finally, option number 7 is counting this with a set. Same problem with a large batch. This becomes pretty much impossible to do, because with 100,000 records, you're now talking about a record in DynamoDB that is just far too large and too problematic to really work with this. So at least with using an atomic counter in DynamoDB, it really doesn't look like a lot of these solutions are going to be very effective here. So whenever I get into this problem where, the road I'm going down is not working for me, I try to take a step back and go, okay, what haven't I considered? What are some of the other options here? And Jan was very quick to point out, hey, maybe step functions would work still. So I dug into it a little bit more and played around with it. But step functions is pretty much immediately a non-starter. And it's not because of the steep development curve in getting these things started. I'd already built 95% of the solution. Actually reworking that into a step function was, or a step function state machine was very quick. It only took a couple of minutes. The problem is that if you have 100,000 records you're trying to process, step functions can't handle more than 32 kilobytes on a state transfer. So as you're trying to move from, hey, here's my batcher, and it's going to hand off all these records to a map that's going to process each one by one, well, that state that you're trying to transfer from the batcher to the map is way larger than 32 kilobytes. You'd be very hard pressed to ever get that into a reasonable size. So again, we're kind of out there. So where does that leave us? Really, I have a couple of ideas about how to solve this. Again, the real big challenge here at this point is actually coming down into the scale of this solution. And maybe your solutions, maybe your needs aren't 100,000 or 250,000 records per batch. Maybe you're looking at 40, 50, 60 records per batch. But fundamentally, if a solution doesn't work at scale, then it doesn't work at all, or at least you can't trust it to work. So really need to go back and kind of start over with the drawing board and figure out what's going to be a better way to handle this. And I have a couple ideas. It's probably going to take me a little while to work through, but expect a third video on this. I wanted to give you an update, at least as far as The comments that were posted on LinkedIn and, pointing out some of the mistakes that I made on the first one, I wanted to address those. I know it took a little bit longer to get this video out than I had intended. But I do have some ideas on how to get this solved in the future, and I hope to do a future video and get you some good answers about highly concurrent, large scale, 100,000 record or more batches and how you can process those through AWS serverless. If this was if we weren't trying to do serverless, there's probably 100 systems out there that we could use. Temporal comes to mind for doing this sort of thing too. But thank you for listening. Again, if you like this content, if you want to see more stuff like it, like and subscribe on the YouTube video. That lets me know that this is actually worthwhile to you. And talk to you soon. Thanks.